Section 4 is going to look at the equation of circles and circles on a coordinate plane. So we're going to look at circles from more of an algebraic standpoint. So the equation for a circle with a radius of r, so it's saying whatever this distance is, if we called it r, and we knew that this exact center right here was at the spot hk, so this is our x value, this is our y value, we could write an equation then and say x minus h, so minus this value, all of that squared plus this amount, y minus k, remember is this amount, take that and square it, equals r squared. So whatever this length is, squared. So this is going to be the standard form of an equation for a circle that we could plot on a graph. So here's that standard form again, x minus h, all of that squared, plus y minus k, all of that squared, equals r squared. So let's see what it's like to actually write an equation for it then. If we need to write an equation for the circle of radius 4 that's centered at the origin. Now remember, the origin is the point 0, 0 at the very beginning of everything, kind of right in the center there. So how would we start writing it? Well, our h is 0, it's this piece here, so we plug in 0 for h. Our k, this value right here, is 0, so we do y minus 0 here. Our radius is 4, that was from right here, so that goes right into this spot. So this would be what our equation looks like at first. We can simplify it down though. X minus 0 is just x, so we'd call our very first part x squared. Y minus 0 is just y, so we'd call that piece y squared, and 4 squared comes out to exactly 16. So this piece here in blue, this x squared plus y squared equals 16, that would be the equation for the circle that starts right in the middle, right at the origin, and has a radius of 4. Now let's try writing the equation for the circle with a radius of 5 that's centered at 1, negative 8. Well, first off, anytime you know the radius is exactly some number there, you can plug that into the endpoint here. We have r squared, so it's going to be 5 squared at the end of that. So we'll know that for sure. When we're centered at 1, negative 8, that 1 gets placed here next to the x, so x minus 1 squared plus, and then the negative 8 goes along with the y, it's that k value, so y minus negative 8, that piece gets squared. So then all of this, everything on this side, equals 5 squared. Simplifying that down, our x side, that can't really change anything, we can't simplify that. Y minus a negative 8. Anytime you minus a negative number, it's the same as adding it. So we'll call it y plus 8. So square that, and at the end, 5 squared is 25. So that will be our equation in the standard form, this blue one. This one is asking us to write the equation for the circle shown below. Well, we can see right here that the center is at 2, 4. So if I move this off to the side, we know that our equation is going to look something like this. X minus 2 squared plus y minus 4 squared. Anytime we know the exact center, we can just plug that into our h and k values. We still don't know the radius though. We need to figure out this length, do it in red, from here to here. We're not sure how long that is, but we can figure out some pieces. We know from here to here, and then from here to here. So in a sense, you can either do the distance formula from 2, 4 to 4, 8, or we can use the Pythagorean theorem, which is kind of what the distance formula is. This distance here is 2, from here to here, that's 2. Going from here up to here is 4. Each of these blocks are moving 2 at a time, 2, 4, 6, 8, 10, and so on. So for over 2 here and then up 4 here, we need to find this distance. So use our Pythagorean theorem. 2 squared plus 4 squared equals r squared. This length, this red one, is r. Well, simplifying that one, 2 squared is 4. 4 squared is 16. 4 plus 16 is going to be 20. So we have 20 equals r squared. So then we can take the square root of both sides to get r alone, and we'd say r equals the square root of 20. So I can plug that in for my last piece here. It's r and then squared. So x minus 2 squared plus y minus 4 squared equals the square root of 20 squared. That would be our equation for the circle. Now we can simplify that a little bit. The x and the y piece, or everything on the left, can't be simplified any, but square root of 20 and then squared, this squared part cancels out with our square root, and it just leaves 20. So this in purple, this last piece here, is our simplified equation for this circle. If you were to plug this into a calculator or some other graphing software, it would be able to graph this exact circle. This one is asking us, graph this circle as it is given to us. So we have x plus 6 squared plus y squared equals 25. Well, first let's rewrite it into more of a standard form. So we have the h and the k. So we're going to rewrite it x plus 6 squared plus y plus 0 squared equals, I'm going to rewrite 25 as 5 squared. If I rewrite 25 as 5, that 5 is going to be the radius then. Now, x plus 6 is the same as x minus negative 6. So this negative 6 right here is going to be part of my center. This 0 is going to be the other part of my center. So we know that the center is going to be right here at negative 6, 0. And because we know the radius is 5, we know it's going to go 1, 2, 3, 4, 5. Here's going to be 1 point. 1, 2, 3, 4, 5. There's going to be another point that'll touch, and 1, 2, 3, 4, 5. So our circle is going to be centered right here and hit all of these points. Now you can make just kind of a general sketch. You don't have to be exact. I'm going to use my circle tool on this. Whoops, I don't want it to be filled in. Let's do circle, the red line. There we go. And I just want it to touch those edges. So here's my center, and it goes through all of these points. Now don't worry too much about sketching in and going a little bit off the graph like this. Just kind of graph this semicircle part of it. I know it goes off your graph on the notes. That is fine. Just make sure you get at least as much of it as you can when you graph it. But this would be how you would graph it. You put it into this form, find the center, find the radius, and plot a couple points, and connect them in a circle. Write the equation of a circle whose diameter endpoints are at 1, 4, and negative 3, negative 2. Now I know on your notes you don't have this graph. This is just kind of a visual to help us see what's going on. So I'm going to plot these points. 1, 4 is over 1 and up 4 right here, and negative 3, negative 2. So I go to negative 3 down to negative 2. So you can kind of see these are the endpoints of our circle, or of a diameter that would be in our circle. So I'm going to draw a diameter in blue here. Okay, so this is going to be the diameter. We need to find the rest of the circle. Well, the midpoint of this diameter would be our center. The middle of any diameter is going to be at the center. So how do we find our midpoint? We take the two x values, so 1 and negative 3, we'll add them together and divide by 2. Our two y values, negative 2 and 4, add them together, divide by 2. That third pair there, this is going to be the x value, this is going to be the y value of our new point. So simplifying that, negative 3 plus 1 is negative 2 over 2. Negative 2 plus 4 is positive 2 over 2. Simplifying that down even more, negative 1, 1 is our new, our midpoint of that, so that would be our center. So right here at negative 1, 1, that is our center. Okay. Now that I know this is the center, I need to find the length of this radius. So again, like before, I can just draw a line over. I'm going to use red this time. Or oops, I guess I got black. 2 over and 3 up. So I can use that to find my radius here. Put it into the Pythagorean theorem. 2 squared plus 3 squared equals r squared. This length was 2. This length was 3. So now we've got 2 squared plus 3 squared equals r squared. 2 squared is the same as 4. 3 squared is the same as 9. And it still equals r squared. 4 plus 9 is 13. So 13 equals r squared. Take the square root of both sides, and r equals the square root of 13. So now I just put everything into place. X minus -1, because of my -1 spot here, all of that squared, plus y minus 1, again because of this 1 right here, that's what I'm subtracting, equals the square root of 13 squared. Now to simplify that, x minus a -1 is the same as x plus 1, and then square that. Y minus 1 stays as it is, and when you square a square root, those cancel out, so we'd just be left with 13. Now if you didn't have the graph, or if you weren't looking at it and didn't want to use your Pythagorean theorem, you wouldn't know this amount. You would be left kind of with a blank right here. All you'd have to do is find this midpoint, and that would be your center. You'd plug it in here. Then take one of these points, like this 1, 4, plug it in here, so 1 and 4. Solve out this expression, so 1 plus 1 is 2, 2 squared is 4. Write that right here. 4 minus 1 is 3, 3 squared is 9. Just do 4 plus 9 equals 13. Which, by the way, is exactly what we got, would be our radius, or our radius squared, would be that 13. So in the end, you don't necessarily have to do this Pythagorean theorem part to find out what this right side of the equation would be. But yes, this black piece, the x plus 1 squared plus y minus 1 squared equals 13, that would be your final answer. That's the equation for that circle. Last one for this video. Given the circle with the equation x minus 1 squared plus y plus 1 squared, all of that equals 16, determine if each point is on the circle, inside of the circle, or outside of the circle. And here's the trick to do that. You always plug in the values of x and y. So this 2 and 4, you'd plug it in, 2 and 4. If the answer you get on this side is smaller than the right side, so if it's going to be less than 16, then it would be inside of the circle. In one like this, what that would be saying is our distance from this point would be somewhere in here. It's less than that total length. If the answer would be bigger than the right side, so if we plugged things in here and we got a number that's bigger than 16, it would be going outside of the circle. Its distance would be further away from the center than the rest of the circle is. And if it's exactly equal, so if this plus this equals exactly 16, it's going to end up being right on that circle. So let's try our first one. For A, we've got 2 and 4. So plug that into our equation here. 2 is our x value, 4 is our y value. 2 minus 1 is going to be 1. 4 plus 1 is going to be 5. 1 squared is 1. 5 squared is 25. 1 plus 25 is 26. And 26 is much bigger than 16, so it's going to definitely be outside of the circle. Okay, going on to the next one. We're plugging in 2 and 2, so 2 minus 1, right here, and 2 plus 1 right here. 2 minus 1 is 1. Oops, that's not going away. There we go. 1 right here. 2 plus 1 is 3. That goes there. 1 squared is 1. 3 squared is 9. 1 plus 9 is 10. And 10 is smaller than 16. So that one's going to be inside of the circle. And this last one, 1 and 3. So we plug in 1 here and 3 here. 1 minus 1 is 0. Oh, there we go. 3 plus 1 is 4. 0 squared is just 0. 4 squared is 16. 0 plus 16 is exactly 16. And 16 equals this piece right here. So this one lies directly on the circle. And that will finish up our first video.